started out deciding to make our toy modeled after the 1950s vintage clapping monkey. And this is a picture of that. Its arms alternate back and forth, clapping the things and the cymbals together. Show you the video first as soon as it comes up. The first step in the process is actually we searched online for a comparable toy with a motor in it that we could use. We actually found one that actually made monkey sounds as it rotated. Oh, okay. Where is it?
I don't think you have it mapped.
Oh, I have to map it.
Go to groups. Groups. And then your group number.
Okay. Sorry about that. So here's the mechanism video. As you can see, the blue part is the purchase motor. It has 4 AAA batteries. It makes monkey noises as it rotates, and it's automated, or what is it? Motion. There's a motion sensor that starts the process. So we initially bought the motor and we designed around the motor the mechanisms inside with the crank disc, the connecting rod, and the slider. After that, we just kind of designed around that, keeping within the volume constraints. Final version. What do you want the ASN?
Well, I can talk about the physical model while we're waiting. A couple of problems we had, just like all the other groups, was tolerances. We weren't quite sure on those, so we did have to do a lot of sanding to put the legs, the arms, and all the connecting rods and stuff for the mechanism. We decided to mount the motion sensor right on the belly here. I don't know if you guys can see that. So we decided to kind of cut a hole in the material. Material we had to buy the fur, obviously, to make it look more realistic. Another problem we had was the cymbals, because in our model they have to be exactly perfect for them to clap right. So we kind of wanted to have some leeway on that. So we decided to use Velcro tape, which allow it to some movement or some compression and movement. What else? Another problem we had when we modeled the motor, we kind of made the bottom. It was kind of hard to get the dimensions because the bottom was curved. So to get that exact curvature, we kind of had to leave some leeway, and we kind of planned on gluing it at first, but the curvature was too much, so we had to use Velcro tape for that. So the motor isn't exact. It's not held in there exactly how we planned. Another thing is, on the model, you can't really see it too well, but there's a spring. We kind of wanted to do a bobblehead. You can kind of see it bobbling. We planned on doing one spring, but we couldn't find a spring that was really strong enough and long enough, so we decided to use 2 springs. And yeah, that's the bobblehead. We'll run it after he's done talking about
Some of our surface models, like other groups have said, like the complexity of something organic, like the face of the monkey, if you just do generic shapes, it won't look very realistic. So like on this face, as you can see here, it's kind of a cylinder, but you want a flat area for the actual eyes and mouth. But if you have it completely flat, it looks very structured and it's too sharp. So we had to use a warp to actually warp the face down on the side, which ended up creating pretty challenging to work around because the warp isn't symmetric. So you end up with a lot of weird interacting surfaces. We use mostly sweeps for the mouth and the lips, and then for the teeth and the eyes, we actually use projections from the back, and we project surfaces up, and then use either for the eyes, we used the sweep, circular sweep to create the eyes, and then the mouth, like I said, we did a projection of the teeth from the back, and then actually just ran trenches down the teeth so that way it looks like the teeth from the original monkey. It's got a lot of complexity to it. Also, we ended up cutting it out and hollowing it. As you can see, we're trying to save volume on the front, but it's kind of challenging with those sweeps to also hollow it out without, destroying some of making it too thin or making it cut into something and then won't blend properly.
The hands turned out to be surprisingly difficult. Each hand is a assembly with six each hand is an assembly with 6 parts in it. The palm and each finger. The palm is in a variable section sweep, and the fingers are 3 or 2 in the case of the thumb, 3 rotations. And then once we got one hand completed, we all had to learn a little bit about mirroring an entire assembly as opposed to just a part. What we had to do is save one file with 2 hands in it, and then go back and delete one hand, so we had one file with the right hand, one file with the left hand. So that was a learning experience for that part. And
So for our physical model,
we'll try running it for you. Probably the biggest problem we ran into after we got all our SLA parts sanded down to the right tolerances to fit is the friction of the crank slider. The slider in the sliding slot with like the bending moment that the arms create on the pin creates quite a lot of friction on the slider, and sometimes it gets jammed, but if we're lucky, it'll work.
yeah,
So,
we ran it a couple times, and in the back position, it'll the motor will like bog down, but then sometimes it'll keep going. So
yeah.
I don't know what's gonna exactly
We turn
happen
on with
here.
the switch, and then it's activated by a motion sensor here. Feel the monkey up to switch it.
All right, so it's on now, and then motion should right there.
Turn it up.
Yeah, so right there, it's getting stuck.
It was working last night.
Yeah, sometimes it'll kind of bog like that, and it'll still come together and collapse. I think one of the problems we're having now is where it's at right now. It's starting in that back position, so we'll try it from up here and see. Well, now it came unhooked, but
Yeah, now the pin came out maybe, but yeah. So that was tough.
Yeah.
Okay, we gotta go.
Yeah.
all right, so.
Thank you.
Uh,